All right, moving on with the linked list. I'm going to go start talking about your lab so you understand what your next homework assignment is. And when we start talking about the rest of this code, it'll make more sense. You're going to first write a singly linked list. That's the first thing you're going to do. And then you're going to write a doubly linked list. The second one sounds like it's a whole new object. It is, but you'll quickly realize that it's just copying and pasting the first and doing a couple of extra things. Singly linked list. Default constructor. I already wrote that. That's great. Other constructor, I'm going to pass you a singly linked list. You need to do a deep copy so that you have two linked lists that are the same. We haven't talked about the destructor yet. We'll probably write that. Get length. I'm going to let you decide how you wish to implement that. There are multiple ways. There are at least two. Append to the end. Hey, we already did that. Push back. Insert at a given position. Ooh. I'm not going to write that. Well, let's at least look at what that looks like. Here we are. Let's say we wanted the new node to come after the 65, aka we did insert of 2, 50. Well, you create the node, right? You get your P, aka rover, you move them down 2 slots. Then you have your new nodes dash next go to the 34, and then that rover is then going to point to the 50, and then you're done. See, it's just simple pointer moving around, right? Right? Yeah. What's that? Yeah, it's just now it's a different position, so you now need to update multiple things. All right, we talked about that. Hey, look, we're going to even look at it some more. That's great. Deleting. Oh, this is going to be fun. Because I'm going to do a remove function. Hey, look, a print. Not going to grade it, but you can do it. Remove, aka delete. You want to delete the 34. You have to find the 34. But notice something. You need to have a pointer to the previous node. Why? Because if you're deleting that 34, you want the 65 to jump over it. So you need to point to where the 65 is. So when you do this, you're probably going to have, you can do it one of two ways. You can have a rover and just be constantly checking rovers dash next dash data value. Or you can have rover and previous, where previous is the one before the rover, and then rover keeps moving on. I recommend rover and previous because it's going to be a little more explicit and easier to understand what you're doing, and you probably will have fewer errors. But either way works. All right, good. Keep in mind of what happens when you delete the final element of a list. It should be 0, your length should be 0, your head should be null, and your tail should be null. Also, if you delete the tail needs to be updated. If you delete the head needs to be updated. All right. All right, we're good, blah, 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 blah. I think that's actually it. Hold on, F5. Hey, the subscript, aka that's the get we just did. Do the same thing we did in class with that operator. Also down here, we have operator double equals to be able to compare two lists as well. All right. And I'm going to show you that I have stubbed this out for you already. There's the CPP file. You can copy and paste a lot of the code we did today into here and already get a decent grade for it. Here's the HPP. We already filled in the private stuff, so you can copy and paste that in from today. All right, there is one last class. One thing we need to finish talking about. It is a doubly linked list. Anyone take a guess? Any guesses? Yes. Well, no, besides you. Enough from you. Okay, so it has 2 pointers. Good. It's pointing to the next. And what would be the other thing that might be useful? Yeah. Everyone got that? No. No? So this guy over here, recording, great, would also point up here. This guy over here would point down here, And then, of course, this one over here would point to null. So you're pointing one going forwards, one going backwards. Doubly linked list. Ah, everyone see it? All right. This is actually going to make deleting easier, because if you need to delete 10, once rover is 10, you have previous and you have next because you have the pointers. So deleting is actually easier in a doubling linked list, as you will find out. Inserting might be a little harder. Just keep in mind you need to update your prev as well as your next. But you're going to do the same thing with singly linked list as with doubly linked list. Once you finish your singly linked list for this lab, basically copy paste into doubly linked list and then just start updating your code. It's actually not that bad as long as you sit down and test it. Any questions? I'm sure you'll have plenty. All right, well, now we have 50 minutes of lab time. Yeah.